thanks for coming. I'm going to talk about Docker for data scientists, simplify your workflows and avoid pitfalls. So I'm Jeff Fischer. I'm an independent consultant, and my company is called DataKen Research, and that's my website. So I want to start with Docker. What is it and why do you care? So how many of you have heard of Docker before? Okay. How many of you have used Docker before? How many of you have been frustrated by Docker before? Okay, good. Well, maybe not so good. Oh, thank you. So what is it? So Docker it uses containers to deploy isolated applications on top of Linux. And we're going to talk about what that means exactly. And it's also an ecosystem of tools that you use for creating, sharing, and building layered application stacks. And there's also a lot of things that are built on top of containers like Kubernetes you may have heard of. So if you're a data scientist, why should you care? So there's people who focus on Docker full time. They're like in the DevOps world, and so they know all the ins and outs. But if you go as a data scientist and look at it, you see all this stuff about control groups and namespaces and sockets and mapping and stuff, and so you might get frustrated real quickly. But if you learn enough to be dangerous, then you can focus on your work and not have to fool with trying to get all the libraries deployed. If you have some kind of complex dependencies, you don't have to kind of fool with all that yourself. You can kind of automate that all every time. And you can also reproduce your experiments, because having reproducible work in kind of the machine learning world is about not just reproducing, having the data that comes into it and having the code that defines your model, but it's also about having the full code stack that you use to create it reproduced. And Docker is a great way to do that, as we'll see. Another thing is to share and collaborate with your peers. So rather than spending a day, if your coworker wants to run what you're running, rather than spending a day trying to recreate your environment, you can go, oh, here's my Docker image, go for it. And it's real easy. And then you can build on others. Docker has this ecosystem, and there's this thing called Docker Hub, which is like a GitHub for Docker, and you can use that and kind of build on what other people have done. Okay, so this talk is based on my consulting work for some data science teams, going and helping them to automate some of their workflows. And so it's based on what I learned and what I found easy to do, what I found hard to do, best practices and pitfalls. And I've organized it around specific tasks, which I'm calling workflows. And it's going to have a lot of coding examples. So I'll show you hopefully running code, assuming everything works okay. And the other thing is there's no way I can give this talk in 25 minutes. So I wrote up a kind of a long version of the talk on my blog, and it's actually in 3 parts. So if you go up there to that, or just remember dataken.org. So the first part was last week. The second part is today, and the third part will be on Tuesday. But it'll kind of follow the same organization as this talk. Okay. So I'll start with one conceptual slide. And I just want to compare different ways of deploying isolated applications. And what I mean by an isolated application is it's something where I'm going to deploy, say, a Python application that has a bunch of libraries, and I don't want to mess with maybe my operating system version of Python, because I maybe don't have the permissions, or I don't want to install stuff there and then find that breaks some other software I have, right? And I might have multiple applications I'm working on, and they all have different dependencies, and I don't want to necessarily mess with them. Particularly you have something that's, some version of this library, and it's something else wants a conflicting version. So one way to do that is using virtualenv, and that it's installable in Python 2.7, and in Python 3 now it's standard. It's called venv, and there's also some Anaconda Python has conda environments as well. So what this lets you do is basically set up a separate Python that's running in your home directory. And you can have multiple of these. And each one then you can run pip to install packages into that Python. And it's not as heavyweight as you might think, because it's not actually making a full copy of all the files. It is, what it's really doing is making symlinks. And it's kind of complicated. What is it? Many years ago there was a PyCon talk by David Beasley talking about how it really worked. and I was totally lost. But it's magic and it's pretty lightweight, so that's another way to go, and it's scriptable. But if you start running into where you're installing complicated libraries and things and dependencies, then you might find it's not good enough for that. And the opposite extreme is a virtual machine. So the virtual machine case, you're basically simulating from the hardware on up an entire stack, right? And so you can run, let's say I can run Mac, and then I can be running Windows in the virtual machine. It can be something completely different. So for there, you have a full copy of everything, the OS, the file system, all the Python, and your application. So you can install whatever you want on it, and that's kind of the most flexible option, right? The downside is it's not very lightweight, right? So it's very heavyweight, and starting up a virtual machine may take as long as it takes to boot the OS. And it's also not very scriptable, so it's hard to automate. So Docker, then our third case, is kind of the happy medium between the two. So with Docker, it's lighter weight than a virtual machine, but more flexible than something like virtual environment. And so the kind of key difference here is, I'll kind of point out, is if you see here, it has its own copy of the system file tree. So everything from / on down, so like user, bin, all those directories, you have your own separate copy of this than you do on the system file tree. So that can also mean it's focused on Linux, but you can have like Ubuntu Linux down here and be running CentOS Linux up here, or something else. And if you're running Docker on your Mac, like I am here, you're not really running, remember I said Docker is Linux only. The way they do that is they actually are behind the scenes running a virtual machine. So, but in production, if you're running it on a production machine on Linux, then it's directly using Linux. Okay, so now here's some of the workflows I'm going to talk about. First, on the right, you see this is what a typical data science workflow would look like. But I'm going to be talking about things a lot lower level. And the idea is these are things that might fit into steps here. So like running a database might be something you're going to do for the kind of data preprocessing step. The training might be done running a Python script, or by running a Jupyter notebook. Certainly to test and evaluation, maybe you're using a notebook for that. So these are kind of lower level things that should fit into various parts of your workflow depending on exactly what you want to do. Okay, so I'm going to start with the first workflow. So what I want to do is I have this script called iris.py, and it is a scikit-learn machine learning script. And I want to run it in a container. And I just want it to run the thing, and it's going to do a train and test and of a machine learning model, and then it's going to print the result and then exit. And then I want the container to go away and not have to install any special software. So the way I can automate that is you start with this thing called a Docker file. And a Docker file is just a recipe for how you're going to build your containers. And we'll see what one looks like in a second. And it's usually called Docker file with a capital D. And you can kind of give it a different name, but by default, and usually that's what it's called. So we're going to run this command line tool called Docker, which has it's kind of like Git, where it has a whole bunch of subcommands. So we're going to run Docker build to create this thing called an image, and that's like the image on disk of what your containers will look like. So all the file system and everything, that's kind of in the image. And you can create multiple containers from this one image, and each container you create, it's sort of like they start out all the same, but then as they change, those changes are not put back in the image. That's just the starting point. So the other thing we're going to need, so we're going to run this build step to create our image, but we don't want to have to specify from scratch, like, oh, I want to start with Ubuntu, and then I want to install, Linux. I want to install, Anaconda and all this other stuff, scikit-learn. So rather than doing that, we can inherit from someone else's image. So there's this thing called Docker Hub, and so that's, like I said, it's a GitHub for images, and we can inherit from the Anaconda 3 image, which is from the Continuum IO. That's a standard distribution, and so they have a Docker image for that distribution up on Docker Hub. And so we use that because it already has scikit-learn and everything we need installed, and pandas, NumPy, all those goodies. So then once we have our image, then we're going to run Docker run, and we're going to run it in what's called interactive mode. And interactive means that it's running on the shell and it'll basically run that container directly in the current shell session. So command line, so we'll see that. So this is, by the way, what the code is that we want to run. For the first example, just real quickly, it's doing a training, and right here, just train test split, training it. Then I'm going to score it on the test data and print the accuracy. So it's doing a support vector classifier on the famous iris example. So this is the code we need to automate that whole process I talked about, not a lot. So the Docker file looks like this, and it has the first word of every line on the Docker file is called a directive, and there's a reference somewhere. There's about 20 of them, and there's a reference on the Docker website. But so the from directive says this is the image that I want to start from. So I'm going to take the Anaconda distribution and start adding to that rather than starting from scratch. And then the first thing I'm going to do is I'm going to run a command, and this will run in the context of my container. So I'm going to run make dir. I want to just create a directory called /scripts. That's where I'm going to stick my stuff. And then I'm going to copy my iris script over into the container from the local directory. So this is happening at the build time, so that whenever I start a container from this image, it'll have this in it. And then this is just saying the default command, if I ran this container, would be bash, which is the shell. I'm not going to do that because I want to do Python. So over here on the right, we have the shell commands we want to run. And I'm going to start by doing maybe this is easier here. We'll do a pull. So this is saying I want to download the latest version of this image and make sure I have it on my machine. And if I run it a second time right afterward, it'll say, oh, you already have the latest, nothing to do. So, it's hopefully today. So it usually runs in seconds. If you've never run that before, there's a new version. It might take a minute or so. So here I'm going to do the build, and I'm saying it has the name PyBay workflow 1 is the name of the image, and dot says get the Docker file from the current directory. And then this is the command, the run command, which will create an image and run it. And this is, again, I want to just run Python on my script. So there's two important options that I have. This IT is interactive mode. So this is saying run it interactively in the current shell. And then this -srm says remove it after you exit. So the actual whole container is going to be created and then destroyed when the script is done. So I'm going to hopefully give you a demo. So this code is on GitHub, like I mentioned. So I can go into workflow 1, and I have this script run.sh, and it's doing exactly what I showed you, except for a few extra echoes. So now we're building the image. We're pulling the container, we're building it, we ran it, we're done. So in 3 seconds, we did that whole process. So obviously, if you have a deep learning model, that's going to take a long time doing the actual running. But you see the overhead of the Docker was very small, right? And we see we have accuracy of 96.7%, which is pretty good, I guess. Okay. So as we're going in the talk, I want to talk about some pitfalls. So one pitfall is, let's say that I had that iris script and it was writing some stuff to the file system. So you're happy to make any changes you want inside your own container. Again, remember that container is isolated from the host machine, because as we talked about, isolation is one of our goals. So all those changes happen in that separate copy of the file tree. So then when I went and deleted, when I killed the container at the end, if I had made changes, they're all gone. So this could be a problem. And let's say you don't have to put that -srm, and you could leave the container around, but you can't use your system file, like the Spotlight on Mac or whatever it is on Windows, or find on Linux to find your files, because they're hidden inside this container thing that Docker is managing. So if you have any data that you're kind of change while running your container, my recommendation is don't put it in the container itself. You want to put it on your actual host machine, which in my case is my Mac. And so the next workflow, we'll see how to do that. So here's our second workflow. So we're going to start. So what I want to do is I want to run a container, and I want to take my current directory and mount it into the container as /host. And I want to be able to make changes there. I'm going to run a shell here, and the purpose of running the shell is that I can go run whatever commands I want. So rather than just running Python and exiting, I want to run some sequence of commands or something. So the process to get there is fairly similar, right? So I have a Docker file. I'm going to build it using the same base image. I have my image, and I'm going to run it in interactive mode, and I get my container. Here's our source code. And so you can see I'm starting again with the same base image. I know this particular image is based on Debian Linux, so I can run any commands that you would normally do on Debian Linux. So I'm going to do apt-get and install vim, which is the, like VI, like editor. So I'm going to install that there. This volume directive is saying that I'm going to be mounting something at /host later on when I start the container, and that's the working directory. So here's the shell commands. So I'm going to pull my container, I'm going to build it, and then I'm going to run it. And you see it's pretty much the same thing except for I bash. And then there's this magic line here, which has this volume, and this backtick, PWD backtick is just shell syntax to say, give me the current working directory as an absolute path, and then I want to map that to /host within the container. So you see a lot in Docker of mapping something from the host to the container and vice versa. So that's the magic that's going to get my host file system. Okay, so let's see that one. So. Okay, it's building. So now you see I have a funny prompt here. Hopefully you can see that. And it's got a pound. So it says root, but it's not root on my host machine. That's root inside the container. So I'm now running in that container. But I can see all the files in my local directory. In fact, I can go Python, iris.py. And 100% accuracy this time. That's pretty good. And I can also maybe save those results. I can edit the file if I want or save them. So I now wrote and I put them here. So if I hit exit, that container goes away, is destroyed. But my out file is still there, right? So what I did then is I basically have a workflow here I can use where I can do work in a container or run something in a container but still have the actual results that I want to keep written to the local file system. So this is helpful. And you can do things like, let's say, have a Git repository here, and so all your code's there, and you can push it up to Git. You can do things like have an IDE or a graphical editor and edit it on your host, and then automate. Basically, you take whatever you were going to do to run your program and just put Docker in front of it, Docker run in front of it, and then have it just run it as a part of your regular automation. Okay. Okay, another pitfall. So I was doing this for one of my projects and was working great, and I thought, this is the way to use Docker. And I got to one of my clients and said, I'm going to try the same thing. And I could not write to the host file system. And I'm serious, I spent like 2 days debugging this, trying to figure out what was going on. And the documentation was not very helpful. It turns out that there's an enterprise edition, that's the one you pay money for, and my client, having lots of money, had that installed on their fancy new GPU server. And that version by default has a lot more security turned on. And so some of the security is it maps every container to a separate sub-user, and it gives it less permissions on the host file system. So by default, you can't write to anything on the host file system. So there is a workaround. You have to basically disable that functionality on a per container basis, which isn't that hard. It's another command line option or two, and you can map your host users into the container. So it runs as you, as an individual user rather than as root or something. So anyway, my blog, rather than boring with the details, it's on my blog. But just in case you run into this problem, that might be what it is. Okay, our third one, now we want to run Jupyter. So this is going to be a little different because we're going to have this container here. It's going to have TensorFlow and Jupyter running. And I want this thing to stick around on my machine. I want it to be more like a service, right? Or as a server, right, I'm running on my machine. And Jupyter has its own little web server. So I'm going to expose that over port 8888, which is the default one for Jupyter. So that's how I'm going to access my container. So the way this works, I'm starting the same way, Docker file. I'm going to use a different base image because I'm using TensorFlow. Create my image. Then I'm going to run it with this -d option, which means detached instead of the interactive option. So here's the automation code. You can see I have my base image. I'm going to copy my my notebook in there. The reason I actually was running this particular one is I was doing a benchmark of deep learning on different kinds of machines, right? So I found my $300 GPU box could beat a 44 core server. So it shows you the difference between GPU and CPU. Anyway, so this thing is kind of a hack. I'm setting environment variable for test because it's needed by, for the password, which is needed by the notebook. That's kind of hacky, but my blog tells you the right way to do it if you want to. I'm going to run the notebook then. That's what this command is doing. So on the shell, it's pretty much the same, pull and build. Then I'm going to run it. And kind of the main differences is use this detached mode, which is a D, -D, and then I'm mapping basically the port inside the container to the port on the host. Because otherwise, if you don't put that option in, you can have any kind of ports listening inside the container, but they're not exposed to the host. And you don't have to map them to the same port that they are inside the container. So if you have 3 containers with port 80, you can map them to 8080, 8081, 8082 or something like that. Okay, let's see this one. Okay, running. Okay, it ran, it did something, it printed this long hex string. So that is the ID of the container. So there's a command called docker ps, which is kind of like the ps in Linux, not quite. So this container ID is the first part of this. So you can refer to it or that, or you can, in this case, I gave it a name, workflow 3A container. So the thing, it says it's been up for 10 seconds, so it seems to be running. So let's see here, yeah. So if I go to here, it wants my password. So now I'm running TensorFlow and Jupyter inside that container and just using my local web browser to access it. So here, I'm not going to run the whole thing, but you can see it's going to import TensorFlow and I can do whatever I want there. So pretty cool. And then it'll stay running until I either stop it or shut down the machine. And there's ways to have it always start up when the machine starts up. Let me clean that up. Okay. So another pitfall. You said, great, I like TensorFlow, I want to run it on a GPU. So you take this and run it on your GPU box, and it doesn't use the GPU. Well, apparently, the reason is that Docker by default does not see the GPU at all. So you have to get this plugin for Docker from Nvidia called Nvidia Docker, and then install that, and then pick a base image which has a GPU in it. And so that's all detailed on my blog. I mean, it's a couple steps, but let me tell you, it's a lot better than fooling with CUDA libraries. If you ask anyone about messing with CUDA libraries, if they've done it, they know it's painful. So the main thing is just remember, if you want to run on a GPU, you need to get this version. Okay, for my last example, maybe I need some water. Okay, for my last example, I want to show you a database. So the idea here is, so far we've looked at running computations in the container. Now I want to use a container as a data service. In this case, I'm using Neo4j, which is a graph database, open source graph database. And maybe in my case, in my project, I was using it. I'm basically storing a bunch of data that I've analyzed there, and I'm making queries against that to do feature extraction. So I want to treat this as an ephemeral resource, just like I did these other containers. So what I do is, and this step will kind of vary depending on every kind of database. Will probably have a slightly different way of doing this. So for Neo4j, what I did is you can create a database from CSV files. So they're like the spreadsheet files. And so I have that with all my import data that gets generated by some earlier step in my pipeline. So then what I need to do this in 2 steps. So I first of all use an image that I get off of Docker Hub. I don't need to make my own image or do anything. I just pull their image, and then I run it in interactive mode. And what I'm going to do is run an import, and that's going to import all the data in and create the database. And this is all on the host here. So I have that sitting on the host, and this container goes away. Then I start a second container in detach mode, and that's actually running the Neo4j server. And I can map my ports, and it works great. So maybe real quick, I think we got enough time. I'm not going to show you. The automation code is pretty simple, but I won't bother with that. So now it's running, it's doing the import inside a container, and it started something up. So then if I go, you see, that was my previous one I killed. If I go to localhost. So Neo4j has a browser, a GUI that runs in the browser. So now I can do match n turn n. So this is the graph that I loaded in, and I created this in seconds. And you say, okay, that's a pretty small graph, but I had a graph of email data that had like 400,000 nodes, and I was able to do this whole process in about 3 minutes. So it can be pretty quick. And what I was doing is I had like 5 different data sets. And so in my machine learning, I want to switch between them and see kind of what results I get for which data set. So I have a command in my environment. I say, okay, enable this data set. Then I run the command, and then I create the Docker image and set up the database, and I can do my machine learning then. Okay, so that's what I have kind of in summary. I say when to use Docker is if you have a complex stack you want to maintain and it's causing a lot of pain, Docker might be a good way to automate it. I mean, if it's a simple stack, then just use virtualenv, but if it's complicated, use Docker. Or you need to collaborate with someone else. When you start going across machines, then you might do it. Or you need to run on multiple machines. And I'll tell you, I once had a case where I had something running on my Mac, then I go do a POC at a customer, and it took me a couple hours to debug because there was a slight change in the code in the version of pandas. So some API, the semantics changed a little bit, and my code was failing. And if I'd used Docker for that, I wouldn't have spent those 2 hours debugging at the customer site. So anyway, so these are why you would want to use Docker. And again, design patterns, treat containers are for kind of computations in a mutable state. Store your mutable state on the host and map it in. Treat them as a cheap throwaway resource. You can always create it again and integrate it in your personal workflow and automation. So that's what I have. If you have any questions, we can take questions, and also feel free to contact me. I'm happy to help and answer questions and take a look at the instructions I have on my blog too. Thanks.
I think we have time for maybe one question because we ran over.
Okay.
Question?
My question is about the GPU Docker image sharing.
Mm-hmm.
So if you have 2 Docker images you want to share with each other, but the host machine is like different because one with, let's say, lower version of CUDA, another one that's CUDA, one with CUDA A, another one with CUDA 9.2. Are there any problems, if you're sharing higher version of CUDA, with the lower one?
I haven't tried that particular thing before. I think it should work as long as the Nvidia Docker is compatible with both, then it'll work okay. And what you would do is create a separate container for each one. So I think it should work. I haven't tried it, so I won't bet my life on it, but I think anything else, or I think we got a minute.